Assalamu alaikum and hello everyone. Today we continue our lecture. As I mentioned last lecture, there are three types of digital signal processing: analog, digital, and discrete signal. And we concluded from the previous lecture that the discrete signal is the most important signal that we will use it in this subject. That's why we need to study and understand what is the discrete signal and their types. How can we work with it? Is there properties? Is there transformation? So we need to understand it so that we can input these signals into the devices and deal with them in the appropriate way. So here, discrete time signal, x of n. What does it mean? What does it mean x of n? For example, we symbolize the signal with x of t, means the t is function for x, means the x depend on t, on the time. So here, x of n, x is depend on function, we call it n. What's the n? It's discrete time. So in this signal, we have a time, but it's discrete. We cut it. Okay? Take a look on this example of discrete time signal. First symbol located at -2. So -2, -1, 0, 1, 2, and 3 represent the time here. Like we say between first place and second place, the time is 1 second, for example, or 1 minute, or even 1 hour. So the important thing here is the amount of time between one pulse or one signal and the other is same time. So at -2, we have a signal. At -1, we have a signal. At 0, we have a signal. And these signals sometimes got positive amplitude or negative amplitude. But this signal, instead of having one time from this place to last place, we cut it to too many places. So let's say, for example, we imagine this is continuous time signal. Means a signal depend on continuous time. Okay? Means the time start from -2 and end at 3. It will be equal 5 seconds, right? So instead of whole this 5 seconds, we cut it to 5 part or to 6 part. Okay. Okay. So to convert the discrete signal from analog to discrete, we use this system, ADC. ADC is a system that converts an analog signal, such as a sound picked up by a microphone or light entering a digital camera, into a digital signal. So analog to digital converter. For example, this figure is sine wave starting from negative part, not from 0. This signal using the ADC system. One of the ADC phase is sampling. As I mentioned previous lecture, we can convert the analog signal to digital signal through 3 phases. First, sampling, then quantization, then coding. So the first phase will change this figure to that figure. Okay? So it actually both figures are the same, but instead of having one part of time, we cut it to too many parts according to the shape of the existing signal. So let's move to the types of discrete signal. Okay, we have 3 types of discrete time signal. Unit symbol or unit impulse, okay, impulse of n, unit step, U of n, and exponential. Okay, here the most common is the first type and the second type, unit sample and unit step. And even unit step, we use it more. It's more common. Let's get introduced with the properties of each types. We start with unit sample. Okay, as you see here, impulse of n, the value of unit sample is 1 when n equals 0, and the value of unit sample is 0 when n not equal 0. What that mean? Let's explain it in a drawing. This line, we call it n. Okay, like I showed it previously. It discrete time or number of symbols. How many symbols do we have? By the way, student, in unit sample and unit step, the number of samples usually is infinity. That's why we see in positive part, we write until infinity. And in negative part, we write until negative infinity. Okay? So when we need to draw a signal for unit sample, it will be like this. Look here. Only when n at 0, the signal got a value, which is 1. 1 means amplitude of signal, okay? But when n not equal 0, in positive or in negative part, the value of signal is 0. The amplitude is 0. That means no signal. So only at 0, the value of signal is 1, but at -3, -2, -1, 1, 2, 3, till infinity, the value of signal is 0. That's the general of unit sample. Very simple. We will take some example later. Okay, what about unit step? Unit step, the second type. What the general here of its properties? U of n said the value of signal is 1 when n equal or more than 0, means non-negative numbers. Okay, so that at time 0, 1, 2, 3, 4 until infinity, the amplitude is 1. And the value of signal is 0 when n less than 0. So in negative part. So at -1, -2, -3 till minus infinity, the amplitude is 0. There is no signal. But even this is the general of these two types, which is unit sample and unit step, doesn't mean it fixed, doesn't mean it will look only like this shape that I show you just now. Definitely there will be transformation, and this figure will change as I will show you in coming example. Okay, as I mentioned before, the most common is the first type and second type of discrete time, which is unit sample and unit step. But here I will focus more on unit step. So just to remind you, the value of signal is 1 in non-negative part, in positive part. And the value of signal is 0 in negative part. The amplitude is 0. There is no signal. Okay? That's the general of unit step. So on this general of unit step, we can do transformation. We can do some change. There are 3 types of transformation. First one is shifting. shifting to the left side or to right side. Let's see this example to understand how we do shifting for the given signal. So we have this example. Find u of n plus 3, or draw u of n plus 3. So this is our original unit step. It looked like that, our original unit step. So student, very important to write infinity here. If you forget to write it, means your signal is specified. So u of n plus 3, what that mean? And originally, okay, and originally the signal start from 0 till infinity. Okay, that's the original unit step. Let's say it 100. Let's specify it and say 100. The signal start from 0. So if say 100 symbol means from 0 until 99. How many symbol we have? In total, we have one symbol, okay, from 0 until 99. So un, we use it when the signal is infinity, okay, is identify. But when n here is definite, we specify it, which is 100 from 0 to 99. So u of 100 become u of 100 plus 3. So u of 103. Okay, here the extra 3, where we gonna to add it? Our signal is already, we have a signal from 0 until 99. We close the signal at 99. We cannot add more in non-negative part. So that extra 3 here, we add it in negative part. Okay, because our signal is like it's locked from 0 until 99. We cannot add any more. So the extra, the given extra, we add it in the negative part. So we will have -1, -2, and -3 until, yeah, and -3. That's it, because +3. So to find the solution here so fast, okay, once we have an example like this with u of n plus 3, that means our starting point is -3. Our starting point is -3, not 0. So +3, we start from -3. Okay, so we draw it like that. U of n plus 3, the figure will look like that. This is 0. One, 2, 3, 4, 5 until infinity. Okay, and we add the extra 3 in the negative part. -1, -2, -3. Okay, students, so too simple. If we have +3, our starting point will start from -3. We have +5, we start from -5, and so on. That's the shifting to the left side. Okay. Now we take example to see how we do the shifting to the right side. That's what shifting to left side. We need to see, take one more example to see how we do the shifting to the right side. Okay, look to this example. Need to draw u of n minus 4. Okay, so this is our original u of n from 0 until plus infinity. Okay, so we start from 0. In un minus 4, the starting point will be from where? From plus 4. We have minus 4, so the start point will be from plus 4. Okay, so the solution will be of u of n minus 4 will be like that. Our start point be from 4, 5, 6, and so on. Amplitude 1 until infinity. And else there is no signal. At 3, 2, 1, 0, minus 1, and minus 2. Okay, so too simple. If in the question we have plus, like previous example, the shifting will be to the left side, means minus. And if we have minus, like here, the shifting will be to the right side, to the positive side. Okay, let's see the second type of transformation. Okay, the second type of transformation is time scaling. Time scaling. Here means multiply, like we need to multiply the signal by some factor or some number. Let's say this example. Okay, let's see this example. The given example need to draw 3 u of n. So that's mean the given example here, the original one is u of n, but here 3u of n, like we're gonna to multiply the original un by 3. So the un, the original un equal 1, right? The amplitude is 1. So we multiply it by 3. So the value of the signal, it will become 3. So our figure will be like that. -2 signal at -1 no signal. Our signal will start from 0, 1, 2, 3, 4 until infinity. But the amplitude here is we multiply it by 3, correct? So the amplitude instead of 1 will become 3. Too simple. So the previous operation was on the n, okay, on the time, and here the operation on the u, which is the value of signal, which is the amplitude. So instead of 1, it will become 3. Same thing for the other examples. Like this example. Draw minus 3u of n. Okay? The original at 1. We multiply by minus 3. It will become the amplitude. Instead of 1, it will become minus 3. So 0, starting from 0. One, two, three, until infinity. And at minus 1, no signal in the negative part. So instead of 1, the amplitude become minus 3. So we multiply un by minus 3. So in shifting, we change the time. And in time scaling, we change the amplitude. Okay? It's too simple. Let's see other example. Okay, this example. If you notice in the previous example, we focus more on unit step, not on unit symbol. In unit symbol, we have only one pulse or one symbol. So not that important operation we're gonna to be here. But let's take this example, okay, with unit symbol. Here, 5 impulse of n. We know the unit symbol that we have one value equal 1 at 0. Equal 1 only at 0. So at 0, the amplitude is 1. Others got 0 amplitude, no signal. So this is the only pulse we multiply by 5. Others in positive part and negative part still 0. The amplitude only will be 0. Okay, only this symbol we multiply by 5. We're gonna to be here 5. So that's the solution of this example. Okay, last type of transformation is reversal or flipping. Okay, in this part we need to include shifting. We cannot solve it directly. Okay, let's see this example. Okay, u here u of minus n minus 2. How to know from the given question that we need to use this type of transformation, which is reversal or flipping? We can know from minus n. If we have a negative n inside the practice, that means we need to use this kind of transformation, reversal or flipping. Okay, how to solve it? First, we draw it without minus n. Okay, so we have u of n minus 2. Minus 2 means our starting point from plus 2, right? Till infinity. That's what we learn in shifting. Shifting in the right side. Shifting to the right side. Because we have minus 2. Okay? Now, we add the negative sign to our operation. How we do that? Look here. From plus 2 till infinity, we need to reverse it like a mirror. We need to move it. It was it was in this part. We move it to other part. Reverse it or flip it. Okay, and it will become so. But don't forget to keep the first symbol. So this part we move it to that part like a mirror. Okay, it will look, it will be like that. We keep 2, then 1, 0, -1, -2, till infinity. Okay, so the first pulse at 2, we keep it, and we just flip or reverse the other part. Okay, so simply reverse the signal to other side like mirror, but don't forget to keep the first pulse same. Don't change it. Okay, just reverse the other pulses to another side. Okay, let's take last example. Okay, so this example, draw u of -n plus 3. Okay, we remove the negative from the n and we take it without minus. So u of n plus 3, that's what I said, we need to include the shifting here. So plus 3 means our starting point from, if plus 3, our starting point will be from -3. Plus 3, we start from -3. So -3 is 2, -1, 0, 1, 2. Okay, all of this got signal, and we have amplitude. We have one amplitude. Okay, until infinity. Okay, that's without minus. Okay, now we need to flip it. We need to reverse it. So, as I mentioned just now, we keep the first symbol and we flip the other impulse to another side. Okay, to the negative side. So it will be like that: -3, -4, -5, -6. Okay, amplitude 1 until minus infinity. Okay, that's it for today. Thank you.